think we're starting. I was thinking like 20 people, but we're like 10. That's fine.
What did you expect, Lo?
I mean, 50 people sign up, but they want for me.
Okay.
So, okay, welcome everyone to the first meeting of the Cybersecurity Club. Honestly, when I signed up to the uni, the first thing I said is, let's go to the Cybersecurity Club, and then I discovered there is none. So here we are. Go to the next slide. So, who am I? My name is Thomas. I'm 3 and something years studying cybersecurity. This is us, my team that won this year's, or got second place in this year's Visa Tel Aviv CTF, which is one of the biggest CTFs in the country. It was a blast. At the start we were like 4 people in the team, and then I decided, you know what, the money isn't worth it, let's split it and win. So we made some teams, we got together and got second place. I have some experience mostly in web security. I disclosed some bugs to the National Cybersecurity Directorate, and I'm trying to learn reverse engineering, but with everything going on it's a bit hard. Today I'm going to talk about cybersecurity in general, but also in the context of CTFs, Capture the Flag. Capture the Flag is a gamified version of cybersecurity where you try to win points by solving challenges. The challenges could be, I don't know, hacking into some web application, reverse engineering a binary, doing some binary exploitation, or just solving some crypto challenges, which can be a lot of things. There's mostly 2 types of CTFs. There's the Jeopardy style, where there's all the different categories we're going to talk about in a bit, and it goes up in difficulty. The more difficult it is, usually you get more points, and the easier it is, you get less, but usually you solve more. Then there's attack and defense CTFs, which are more advanced CTFs, because instead of just trying to hack different applications or different challenges, you are also trying to defend from other people. So you have your own server where there are vulnerable applications, and you have to secure them against other players, which at the same time are trying to do the same, attack and defend. So the categories of cybersecurity, obviously these aren't all, but there are a bunch. We're going to talk today in great detail about 4 of them and describe the other ones. Web security we call web, reverse engineering is just rev. Binary exploitation we call usually PWN, it's like own but with a P. Y is like a long story. Cryptography is crypto. When I say crypto, this isn't about crypto coins, so whoever's degenerate about that, that's not it. We have open source intelligence, that most people call OSINT. Then there's forensics, which no one likes. MISC, which is just some weird challenges. Professional programming, this is mostly lead code and stuff like that. Blockchain, for the degenerates, this is the cryptocurrencies. And hardware and mobile are usually pretty rare because you need some tools or stuff that are very specialized. So first I'm going to talk about web. Web is the biggest thing nowadays, obviously, because like your bank, Superfarm, that guy that sells antiquities, there's like the thing they have all in common is they all have a website. So if you go into web security, you're going to have a target-rich environment, meaning there's a lot of stuff you can check. When learning web, what you usually get is knowledge of how the web works, obviously, the different technologies, the different programming languages, the different stacks, which are different technologies put together to make the websites work. And you will learn usually how to exploit them, which is like the fun part, and how to secure them, which is also important. And on the challenges I like at least, what you learn is how to read code in a proficient manner, and how to spot vulnerabilities, and also how to fix them. And I say JavaScript and SQL, it's an example. I hate JavaScript, but like that's what you need to know. SQL is another of the important languages you need to use, but also learning about the stacks of different technologies. You have Python, PHP, Ruby, C++ for some reason. So next, please. So Now I'm going to show you the first challenge. I like this phrase, any sufficiently advanced technology is indistinguishable from magic. So there's a good chance you won't understand everything that's going on here, but if you become interested of what you're seeing, I recommend you look deeper into it. So let's look at the first web challenge. First, some definitions. What's a vulnerability? You can read it, but basically a vulnerability is some problem in the code, in the settings, or in the just a structure of whatever application you're looking at, which attackers can use to gain some advantage, be it steal information, get execution of code in whatever environment they're looking at. An exploit is just the piece of code they're using to exploit that vulnerability and get access or just steal information. Okay.
Just press OK and click on
Slideshow, yeah.
slideshow.
Yeah. Okay.
Excellent.
Yeah. So, real tricks. This is a challenge I enjoyed a lot. Like we had it during DCTF this year. DCTF is one CTF that has qualifiers, and then you get to go to the finals if you get to the top 10 and fly to Romania, I think was this year. My team got like 8th place, and in the finals they got 5th place, so some guys went there. I was here, so not great. Basically, the idea of the challenge is you have different movies that different users can sign up into to like have in their watch list. And there's one of the movies that the title of the movie is a flag that you have to get. And the only user that can see it on his watch list is number 1, the admin. But it's banned. Banned is one characteristic they have that changes how it works. So here, this is the watch list. You can see here if the movie is banned, then the movie is popped, which means the user can see it on their watch list. If you don't understand the code, don't worry. This is Flask for Python. It's just a framework to do web applications. So normal users can't see banned movies on the watch list, but this is important. This is the first bug you find, is they can add it to the watch list, which means they can't really see it, but they are on the list of people that have it on the watch list. This will become important later. And one other thing that is like not necessarily a bug, but you have to keep in mind later, is that usernames can be really long. In this case, it's 1,000. I later changed it to 10,000. I'll explain why later. But on the real challenge, there was no limit, which made the exploit a bit easier. So this is the first bug you find, the first vulnerability. You can report some movie to the admins, like in case that it was a real website, this movie has like something children shouldn't see or something. That's the idea. But because of the way it's doing it, you can break how it's supposed to work. And instead of giving you a movie, what it gives you is whatever you want. You can report a movie, another @ symbol, and you can report whatever website you want. It's like when you're trying to sign up to a server, and you put your name and and the IP, and then you sign up. This is what we are using here. We are using 127001 as the username, and after the actual place they're going to sign up into. So, do you think the exploit will work? What do you think it is? People who already have heard about vulnerabilities. Usually, in web you have like XSS, which is like you can inject code into the website to get some execution in the context of the admin. Anybody here has a bit of experience?
I don't remember how it's called, but it's when you make a website go to another website, or
that's one vulnerability. That's Open Redirect.
yeah.
That's one of the vulnerabilities, but the thing in conjunction is a bit better. So play it. So what I'm doing here is using a script to send to the website a report to my own website over here. So I click up there and send the report to my own website. And here, my website does something, and you can start seeing here, the flag is showing up. But what's happening, right? It's kind of strange because you can see on the code itself anything that's like vulnerable to the point that you can send to yourself the flag. But still, you manage it. Go to the next slide. So what's the vulnerability? If ESC. Yeah. No, not that. I'm kidding. What? You go for it.
I didn't go for it.
Yeah, I'm kidding. So access search. Access search is a more advanced technique. Instead of just being able to send some input to a website and it letting you just execute code, what you're doing is checking a timing difference. So what happens? You remember that I could put any username that's really long, and then I could search for some movie which looks like the movie I'm looking for. It didn't have to be the exact match. I don't know if I mentioned that. So I can make a really, really long username or more, and I can also look a movie that's like the one I'm looking for. So what can I do? Well, I create really long usernames, and I put the movie that I'm trying to leak into their watch list, and then when the admin looks for it in the watch list, he'll get a slowdown. So the website slows down at that point, and because the web is marvelous and we can check that, we can just send it to our own website and access that website and just see how long it takes. Go to the next slide. So this is the exploit. It's a bit convoluted, don't think too much about it right now, but basically what this does, it grabs all the URLs we need, the register, the login, the add movie to whatever user we want and report, and then we have a list of unique letters, so I can generate usernames that are, in this case, 500,000 digits long, which is fun. And then I log into that username and add the movie. The movie we know is 30, but we don't know what it says, to their watch list. And then after we do all that, we just make our username which is random and just send the evil request to the report. And this is where the actual magic happens. What we do here is first, we say all the printable characters that can be on a movie title, and we know that it starts with this string because it's in CTFs, it works like that. And basically, we go to the printable through all the printables and check the progress plus whatever printable we are on, and we just check if that movie slows down the search. And if that's true, then we know we hit the right thing. And this is basically the same. Just check the printable. If it's over some threshold, we just say it hit and we add, and then we send it to our webhook. So yeah, this is create user with long usernames, add one movie to their watch list, host the exploit in whatever website you want, and then report at and whatever every website we made. And we use the timing difference to check. This is a new exploit I wrote during the week to show you better how it is. Basically, it's the same thing I just showed you, but instead of using just requests, what it does is puts it on an iframe. An iframe is like watching YouTube on another page because it holds it there. Basically that. Yeah, epilepsy warning if anybody has a problem with that. So here I gave myself admin to see the movie, and now it's doing the exploit while I'm watching it. So it goes through the different characters, and when it hits one, you see it slows down, and then we know it hits. So it keeps going, and like that, it starts building the flag we're looking for. This is usually what the admin sees, not what I'm saying. But just for demonstrations, this is how it works. Just goes one by one, and when it slows down, it hits, and we know we're on the right track. And then usually when it hits the closing bracket, you can stop it, but I just said whatever, it's going to die anyway. So here you go. It hits the whole flag. This is also sent to our webhook, so we can see it. And yeah, that's it. This is more information on the attack. Excess search is from a family of vulnerabilities called excess leaks, which are a combination of searching. Also, you can check different pictures if the user has looked at them or not. It's a great talk and a great white paper. I left it here. I left here the link if someone wants to read it. I haven't. It's super long. Okay.
Today I'm going to present about crop.
I think that's it. Yeah, so this is webhook.site, the place I use to host the exploits. You'll probably use it. Eventually, Burp Suite is the most popular, we call it proxy for web security. Basically, you can see what your requests are before they are sent to the server and also before they hit your own browser, so you can change stuff on the fly. Kaido is the newer version of this. It's open source. That one is a professional tool. CyberChef, if you're interested in web security and also in cryptography, you're going to see it a lot. It's used to transform different encodings, so you can change it from base64 to ASCII to whatever you like. And FFUF is just a fuzzer. I'm not going to go very deep into what fuzzers are, but basically if you want to test a lot of inputs for a website or something, this is the kind of thing you would use. Go on. So I'm me for now. I'll be back later.
Let's just try to switch everything over to my computer.
Oh, okay, so we just plug in this?
Yes.
Plug in this and I'll switch with you.
Can you bring me the adapter? By the way? Thank you.
The Discord, yeah.
Mute yourself, or like
My microphone,
In Discord.
Cool.
in Discord. I'm muted in Discord.
Oh,
No,
you're
your
probably
sound.
outplaying the audio to HDMI. That works.
Better?
Hopefully that-
Okay, so I guess for my part we are going to see only the camera and hopefully.
You have the presentation open. You can also.
Yeah, the presentation is okay. I guess you won't see the demo on screen, right?
I mean, I can send like a link or something to.
No, the demo. I'm doing the demo live.
Oh, right.
No, you're going to see it on the screen and also on the camera, so it's fine.
Okay. Hopefully it will be understandable enough. So cool. Okay. So let's start. My name is Yair. I'm currently a first-year student here at Computer Science and Neuroscience. I'm also like 6 or so years in the cybersecurity field. I'm currently working as a security researcher in a company named Sci. They know nothing about this talk, by the way. Now, I mainly focus on malware development, low-level development, Active Directory attacks, and stuff like that. EDR evasion, antivirus evasion, if you know what it means. And I love to talk about cybersecurity in general, so if you have questions about anything that I might be able to answer, feel free. Something I want to talk about before I begin my part of this presentation is that I have a lot of coworkers who work as security experts and hackers, basically. Most of them don't have a degree, and most of them never did anything technological in the military. So what I'm trying to convey is that if you want to see yourself, if you want in the future to work at the cybersecurity field, a lot of it has to be self-taught. You can find some cool courses online, some are free, some are not, but whether you find a job and whether you will enjoy it or not, really depends on your ability to learn, to be self-taught, and to and to motivate yourself. Some stuff you're going to see is illegal, technically, I think. So everything you're going to see is for educational purposes only. Do not try this at home, whatever the usual disclaimers. So I'm going to talk about two topics that I'm not an expert at, but you will see some demonstrations live. The first topic is reverse engineering. Now, reverse engineering in general refers to a concept where you take something, you break it apart, and you learn how to reconstruct it again and create a copy yourself. For example, Iranians are really good at taking our weapons, our physical weapons, breaking them apart and creating their own version of these weapons, missiles or whatever. In the computer science field, reversing means usually taking a binary apart, an executable usually, and understanding how the code was written. And it is not very trivial. Let me just quickly go over about what's written here. So by learning reversing, you get a deeper understanding of the inner workings of programs and the operating system. Excuse me. You get some knowledge about the different architectures, 64-bit, 32-bit. It's a bit different. And you have the ability to understand low-level code. I'm going to talk about assembly in a second. These are some popular reverse engineering tools. We have WinDBG, GDB, Ghidra, and IDA. Everything you are going to see today, I have done with the free version of IDA. So technically, you can do it yourself, but once again, don't try this at home. So when you write code, you are writing in something that is known as a human-readable language, or I guess high-level code. And your computer cannot really understand that language. So you do something that is called compiling, right? You run the command that starts with GCC, which is a compiler, and it gets translated into this. You have something that is called a bytecode, which is different values in hexadecimal, and you have the human readable version of the same thing. So 55 means push something to the EBP register. I'm going to explain what registers are in a second, etc., etc. So this is the thing that your machine understands, and every time you write code, you have to transfer everything to a machine-readable version. Decompiling is usually the process of trying to take this thing and trying to guesstimate what was the original code that was written in a human-readable form. Some stuff that you cannot see, for example, is the name of variables, because for the computer doesn't need to know what the variable is called. So when you decompile, a lot of times you will see that variables lose their actual name. They're just called like var01. Any questions? Okay. Debugging and patching is the process of taking an executable that already runs on your computer and then changing it a tiny bit, or trying to understand how it works, how the memory looks at each part of execution. You know debugging mainly from writing code in C, I guess. And there you usually focus on looking at the memory and running the code line by line. Here we're trying to run the code opcode by opcode, instruction by instruction. Okay? Now we pray to the demo gods, and hopefully this demo will go fine. So, what I have over here is a virtual machine that has a game that was released in the year 97. Where is it? Oh, it's not here. It's a virtual machine, so it's a bit slow. This is the game. Does anybody recognize it?
Yeah.
Captain Claw? Cool. So we have a little problem with this game. We will see it now. This is the original version of the game. So the game requests you to insert the CD into your computer, because that's the way of the game to know that you actually bought the CD and that you haven't copied the CD from somebody else. Okay? Generally, it is called DRM, which stands for something that I don't remember. but it means copyright protection, basically. Now, what we want to do is to circumvent this check. Now, everything that happens when you run an executable happens on your computer, and you have control over your computer. So technically, you can tell a program how to run and what to do. So we will see that live. Here's IDA. IDA shows me the executable. No, it did not work correctly. Go away. IDA shows me all of the assembly instructions in the executable, and it does that in a very nice and visual way. Yeah, it shows everything in a graph. And what we want to do is to understand at which exact part of the code this message pops up. Please insert the clause CD-ROM into the drive. So what we can do is to search by text, please insert. Since I'm just looking for a smaller section of the string itself, the search will be a bit faster, but it still takes time. So let's see if I left myself in the notes the exact location, just to speed things up. Oh, it found it anyways. Okay, so what we see over here is that the code is about to tell Windows to pop up a message box, and in that message box we have the title and we have the text, please insert the clause, whatever. And what we can see is that before this happens, some other code runs, but we have this specific line of code that has one of two results. It either goes here or goes there. You have either the red path or the green path. And that is the last decision your computer takes before showing you the error message. So we can guess that this is the part where the check happens. Now this instruction over here is called jump 0. It checks for the 0 flag in the memory, which either holds 0 or 1. And if it is 0, it goes to the green path and then shows you the message. So let's run the program with a debugger. And before we do that, we just tell our code to add a breakpoint. Okay? Adding a breakpoint basically means run until here, stop right over here. Okay? I need to run IDA as an administrator. Yeah.
That's always good.
Funny story, the reason I need to run it as an administrator is because the game tries to run in a compatibility version to work as if you're running it on Windows XP. And to do that, you need to have admin privileges. Okay, back at the same spot. Let's try it again. There we go. The code stops. Let me just make it a bit more visual. Move here. There we go. And now we can see this instruction has not run yet, but IDA is already telling me this is what's about to happen. It is flashing because we are going to go over here. What I'm going to do instead is I'm going to the 0 flag in memory, right over here. It is 1 right now, and I'm going to set it back to 0. And now the other arrow is flashing. I'm telling IDA, thank you. You've done good. Please resume. And there we have the game.
Not time to play now.
Yeah, really. And I'm really thankful for the fact that the speakers are off because it's really loud. So let's say I do not want to open this very heavy program each time around the game. Okay? There is some stuff you can do right now. If I understand the code correctly, jump 0 means do not keep going on your regular path. Jump to a different location if the flag is 0. So one thing I can do is to just completely remove this instruction, and then the code will go sequentially from here to here, and then here it will return, and this part will never run. Another option is to turn this flag around. You can tell it instead of jump 0, jump not 0. and then the colors of the arrows will flip. So let's do that. We have patch program right over here, change word. 1874, I think it's little endian, so it's like the other way around, but 1874 means jump 0, and 1875 means jump not 0. You can see the change.
You can change it in the assembly. You can change it in the assembly code. If you go to edit and patch assemble, there is an option to just write an N in it.
Okay, didn't know that. As I said, I'm not an expert. So I've just done that, and I want to run it again, so I have to tell IDA to patch the program, apply patches to input file, it will change the input file itself, and if I've done everything correctly, I now have something that is called a crack, which means a version of the executable that will just work without any DRM. So I can just take the executable, copy it, send it to somebody else, and it will work in their computer as well.
The thing is, it wouldn't work if the DRM is actually inserted.
Right. That's why it's better to just remove the instruction itself, but I wasn't sure how to do that. It just works. I wanted to sleep anyways.
You can also,
we rushed it a bit.
You can also add the instruction that sets the flag to the value you want.
Yeah,
And
or just a jump, but whatever.
Yeah,
That's
there's a lot
awesome.
of ways.
That's awesome.
IDA knows how to fix everything to the labels, or
What?
like let's say that I add an instruction, so all the jumps to the labels will be different because I shifted all the code.
Yeah.
in a couple of
Yeah,
times.
okay, so at this point specifically, if I want to remove this instruction, like the way I would do it is I would look at how long the instruction is. Yeah,
Okay.
add nops, but you have to add nops in the correct length. Because if the instruction, let's say, was 6 bytes, you have to fill it with 6 bytes of nops. By the way, nop means no operation, in case I haven't said that. Okay, for the next demo, it's going to be a bit similar. What I'm going to talk about is binary exploitation. We have a code that is written by somebody else, and that somebody is still running his code on his computer. And I cannot modify the way the code is written. I want to find some kind of vulnerability in the way the code is already written. Okay? Either that, or there's a lot of things that you can do with binary exploitation in general, but in general it means that taking compiled code, understanding how it's built, and abusing some kind of mechanism to do what you want. Keep on going. So some examples for tools for binary exploitation. So originally we had only pawn tools over here, but I told Thomas I know nothing about pawn tools, I just do it raw. So we're going to see IDA again, and we're going to see some script I wrote in Python that does everything for this demo. Before we start, some terminology. We have RCE, remote code execution. It means running code on somebody else's machine, somebody else's server, etc. We have shellcode. We have seen bytecode before. Usually when you compile your program has a lot of fluff, a lot of additions, and etc. Shellcode usually means some standalone executable bytecode, which is very small and usually malicious. FTP is just a file transfer protocol. We are going to see a server that has an FTP server on it, meaning that you can send and receive files from that server. And a register is a small section of memory that stores a value for a specific use. It's a bit more interesting than that. It's closer physically to the processor, if I remember correctly, but I won't go into that. We're going to see one specific register that really interests us. So let's talk about the memory of a given program. Once again, more complicated than that, I'm going to oversimplify. We have a piece of code that, let's say, looks like that. We're getting some input from the user, and we're going to save it inside a buffer. So let's say our memory looks like that. We have the buffer right over here, and after that we have the EIP. EIP means extended instruction pointer. Extended has something to do with the architecture of your computer. Instruction pointer means what is the next address in memory that I'm going to run. Okay? So by changing this value, I can tell the program, you do not go like sequentially, you go to somewhere else right now. For example, if we had some instructions that ended with jump 1, 2, 3, 4, the EIP would change to 1, 2, 3, 4. Understandable? Cool. ESP is once again extended stack pointer. It points to somewhere in the stack. The reason why it isn't like pretty and centered like all the others, we're going to see that in a second. So we had our code from before. It had a buffer that could hold 8 characters. And we are inserting the 8 characters and everything is cool and fine. But if we insert some kind of text that is longer than 8 characters, the buffer will overflow. Why? Because you give your computer like a bunch of text, right? Like a string, a byte array, whatever. And the computer knows that it needs to start writing over here, and it will just keep going. In lower level programming languages, usually there aren't built-in checks, protections against buffer overflow unless you use secure functions, etc. So as you can see, we have overwritten whatever was written inside EIP, and we can keep on going to overwrite whatever is in this section of the memory. So what I can do is insert a bunch of garbage, this is garbage, and then insert my malicious code, my malicious shell code from before. This specific malicious code, you will see in a second what it does. So I've put my code right over here. Now I'm going to change the garbage a little bit. Okay, so this is my garbage, I fill up the buffer, and then the next instruction is go to the ESP. Now we have a little problem right over here. The ESP does not point exactly to the location right after the EIP. It points somewhere in the middle. A camera all this fun?
It was Thomas's idea.
So do you have any idea what we can do at this point? If the ESP points in the middle of our malicious code? You have answered already? Anybody else?
Add it with more garbage.
More garbage? More garbage is problematic because if you put the letter A, for example, right? And let's say A does not translate to any processor instruction, the program will probably not know what to do, or it will do stuff that you really do not expect it to do.
Okay,
But you were really close.
Add it with knobs.
Exactly. So I just put a bunch of knobs over here. It's called. It's generally called a knob sled. You can imagine that the code reaches some kind of knob, and it just slides along until it reaches the malicious code. And for me, it doesn't matter if the ESP pointer is here or here or here, as long as it's inside my knob sled. Questions? Let's see it live. So, this is our machine. This is, let's say it's a remote server, okay? And it has this FTP server. That's a real program. It's very well known because it is broken, and people usually use that for this exact demo. It's like, I don't know, baby's first FTP server. It looks weird. But what I'm going to do, I'm going to attach a debugger, once again, IDA, to this server, so we can see live what happens in memory as we break it. Yeah. That's the correct word. So the server is running. This time I'm not telling IDA to run the process. I'm telling it to attach to a process that is already running, because it crashes if I do it normally. I have no idea why. IDA tries to attach, and then it tells like I'm attached, but it stops. We let it run, and we have the server running. Now, in my computer, this is a different computer. We have this code. I'm connecting to my victim in port 21, which is the port of FTP. I'm sending to the buffer this command, which this command is a problematic command that it is broken. And we're sending 3,000 characters of garbage. By the way, are you okay with Python?
Some of us, yes, some of us no. So.
I wasn't bothered to do the same thing in C, so
Yeah.
Python it is.
I mean, Python
Yeah, God
is
bless
very-
yourself.
I'm opening a TCP socket and sending my bunch of garbage to the server. Let's see it. So I'm running it. The program stopped, finished running. We are going back to the server, to the other machine, and we can see that IDA warns us that it crashed.
Can you go over again what is the shellcode?
Yeah, so as you can see, we have a program that has a lot of opcodes, right? That is how compiled code looks, usually. Shellcode is like a much smaller version of an executable, and it usually is malicious, right? Cool. So we can see this shows us the memory. Hopefully you can see it fine. You can see all of the 41s that we have inserted over here, right? 41 in ASCII, it's the letter A. You see that we have a lot of that, and you can see that it has gone all the way and reached the EIP pointer. Okay? Now we face a really interesting challenge. How do we know how big the buffer is?
We can
Test it and find out.
So, as you can see, it took me a lot of time to run the FTP server, connect IDA, wait for IDA to connect, and then let it run again. If I'm just doing a different number each time and check where it crashes, it will be a bit annoying. So instead, what we can do, instead of just sending a lot of generic garbage, we can send a non-repeating pattern. It's a pattern that like every 3 letters are unique, and then we know exactly where in that pattern it's entered over here in the EIP. Instead of talking, I could just show it to you. It will be a bit more intuitive. So let's do it again. Run the server and attach. Debugger, attach. And this is the code that generates the pattern. You don't have to understand it because you will see it in a second anyways. Okay, there we go. We go ahead. We run. This is our pattern, okay? Just AA0, AA1, and then it goes to AB0, etc. You can see that the code crashed once again. We look at the EIP and we see that there is a specific value in EIP. We convert that value back to ASCII to understand what we are looking at. So that will be, once again, little endian,
Yes.
big endian, it's the other way around. So I have to copy it in reverse pretty much. So that will be 36, 43, 46, 43, 6F, and 37. And this is what we got back. Let's see if I have it ready. I don't. I'll just put that right over here. Copy our entire pattern. Put it over here. Copy, paste, find. And there we have it. Let's do it again. That's the exact place in the pattern that enters the EIP. I will select all of the text, and you can see right over here that the selected amount of characters is 2,000. Now we know that the buffer is exactly 2,000 characters long. Okay? Cool. Let's do another test, just to make sure that we are doing everything correctly. We're going to turn off the server, turn it on again.
It's not 1,000 because each letter ASCII is 2.
yeah, it's 1.
I'm not sure what's the size of the server of the buffer in bytes. I just know that it is 2,000 characters. Okay. We have it running. We're going to run this step just to make sure we are correct. So we are putting 2,000 times the letter A and then 4 times the letter B. This should enter exactly the EAP. And then 1,000 times the letter C. We run it. It crashes. And we can see in the EAP that we have the letter B, 42, exactly 4 times. Cool. So now that we know the exact location of the EAP, I'm going to run the server, and this time I'm so sure of myself that I won't even touch a debugger. This is what I'm going to do. Once again, sending the malicious command, entering a lot of garbage to the buffer, and then I'm sending to the EAP some specific location that will then jump to my shellcode, okay? It's a bit more complicated than what I showed you before, but I don't want to go into it. This is our NOP sled, 32 characters of NOP, basically, do nothing, and then there's the shellcode itself. The shellcode gives the computer the instructions to open a bind shell on port 1144. Bind shell means that I can run code on the other computer.
It's like the laser?
Yeah, reverse shell connects back to me. Like I open a port and I tell the attacked machine to connect back to me. Bind shell means that I open a port on the victim and then I connect to it. See it? So, the program has something that is called a main thread, and the main thread... Did I break something?
I thought that was the idea.
It shouldn't have crashed. Let's try again.
That's why we make videos, cheap people.
Yeah. Okay, let's say that didn't happen. So we have the server. Yesterday it works. It worked. We have the server, we have our code, we run the code. Now the program itself is frozen because the main thread of the program usually waits for some kind of input. It waits for us to click on the buttons, to click on the menus, whatever. But right now it doesn't do that. Right now the main thread is occupied with our bind shell. So this thing freezes and we connect to the other machine. Some of you can already notice that I am running CMD inside of my victim, okay? Let me just make sure you understand. This window, this black window is on my computer. Everything else is on the other person's computer, on the server. Now I'm running a bunch of commands just that you can see that I'm actually running commands on somebody else's computer. I did something. Actually, I'm not sure if you can see it in the video in the end. Hopefully you do. Yes, you do. Okay. And that is proof that I am that I have access to somebody else's computer. Any questions?
Cool.
Okay, thank you. That was my part of the presentation.
Well,
back to Thomas.
Yeah, I'm sure you're glad that I brought him here to explain something he knows and I know jack shit about. You can take a picture of any
So that specific computer ran a program that was vulnerable, and that program No, I asked him.
Yeah, he asked me to take pictures. So, yeah, people, if you want to take pictures, please take pictures. We're going to upload it somewhere, sometime else. So, okay. So, first I'll start with a disclaimer. I'm the worst person in crypto ever, like by far. So this is going to be rough. So, is someone here interested in cryptography or wants to be one of the things? So, well, crypto obviously is really important nowadays. Every communications between two computers need some type of cryptography in the middle if you want it to be secure, beyond like another 50 reasons. But people who learn cryptography usually get a deep understanding of the math that goes in the cryptography, so how it works, why it works, and the thing that's really important in the challenges for crypto is to understand the implementations, because usually the math is pretty sound. A lot of people who looked into it, they got to the conclusion that the math is sound, but sometimes the programmers just don't do the program correctly, implement the math wrong, So there are problems in the implementation, but not the math. So we're going with a challenge right ahead. I helped solve this challenge, but yeah, like I helped, I wasn't the one actually solving it. But I'm going to try to explain it the best I can. This was a challenge in B-Size Tel Aviv 2023. I didn't play in it, but because the solution to the challenge wasn't the one the writer wanted, he used basically the same thing with some fix on the next year, so that people used the intended solve. All the basics belong to me. So the idea of the challenge, there's a flag that is an environment variable in the computer, and it gets to the variable flag, and there's a command. We can execute different commands, and one of the commands is get flag. The problem is all the commands get hashed and get checked against one command that the program wants you to run. The only command you can run is greet. It says hello, name, and how does it work? It grabs, if the data type is a dictionary, it does an XOR with a hashed content from the other command. So basically, it grabs the first command, it does a hash. A hash is just a function that grabs some input and does some calculations to get some output that looks random, but it's not random. It's designed in a way to look random and to be hard to reverse, but the output for the same input is always the same. And it just grabs the bytes and does an XOR with all the other hashes for the command, and that's what it checks, if it's a greet or not. So what is allowed to greet? Then everything gets checked with an authentication, and the commands work like this. Just you have the name of the command and you do the authentication and check. So what's our goal? Our goal obviously is to bypass these checks and get the command we want. But how can we do that? We have a hashed function, right? We have to bypass something that we're pretty sure is unbreakable. So the idea for the solve comes from two videos. I saw these videos some months before the competition, and when I got told about this challenge, I said, wait, I've seen this before. The idea is that the more you play and the more you see about different challenges and different solutions to problems, you get some knowledge to use the previous things you learned and apply it, and that's the overall idea of everything. Can you go to the next one? Yeah.
Software update was a crypto We are challenge going to from solve the...
Okay, so what's the solve? First of all, raise your hands if you haven't done linear algebra yet.
What do you mean by haven't done?
It means we are not taking linear algebra. Only me and like the people from the English program haven't. If you have taken or started taking linear algebra, you're going to get a way better understanding than me on this. So good luck. The two things we're going to use to solve this challenge is linear independence for vectors and finite fields. Can you go to the next one? So linear independence, like all of you probably know, is when you have vectors in different vector fields. Basically, you can get to a certain point in the vector if the amount of vectors are if the amount of linearly independent vectors are the same as the amount of dimensions of the plane you're working with. So if you're working with 2 dimensions, you only need 2 linearly independent vectors. If you have 3, you need 3. If you have 5, you have 5, and so on. Something's going wrong?
No, nothing worried about.
Great. Finite fields
If you
are...
want, I can say the definition of linear independence a little bit like more formal.
Please.
Okay, sure. So you have a set of vectors, like a group set, whatever. And this set is linear independence if all these vectors are independent. What does it mean? That we take any vector from the set and we cannot get it by adding all other
combination
vectors.
of the other
Yeah.
vectors.
So basically, if you have, for example, a 0 in the set, then you can take all other vectors, multiply them by the scalar 0, and get a vector 0. And that's why it's not independent. But if you have a set of vectors, for example, 1, 0, 0, 1, you have no way to get vector 1, 0 from multiplying vector 0, 1 by the scalar. And that's why it's independent.
And again, something you probably know more than me, Galois fields or finite fields, in Hebrew it's yeah. Yeah. So basically, the idea about finite fields is that you have an amount of spaces of numbers you can get. So if you're at 0, you can add 1 and you're at 1. But if you add 1 again, you're back at 0. You can go over 1. The thing is, when talking about bits and bytes, you can achieve the same thing as a finite field of 2 with XOR. So if you have 0 and 0, you got 0. If you got 0 and 1, you got 1. 1 and 0, it's also 1, and you got 1 and 1, it's 0. So basically, it's the same idea. You can see it here. When you're XORing two different characters, it's the same as doing the sum of both in the finite field of 2. So 0, 1, 1, 1, 1, 0, and so on and so forth. You get an 8-dimensional vector added with another 8-dimensional vector in a finite field of 2. So then what's a SHA-256 hash? It has 256 bits, and it's a huge vector. And now what you're doing in the program is XORing the different vectors together, which we can use linear algebra, of all things, to solve the challenge. So we need enough linear independent vectors to get through all the different 256 different planes. Yeah, I think. So what we need is 256 linearly independent vectors of 256. Then we add them together to create any point in that space. And we use the 256 linear independent vectors with XOR to get to any point we want. What does that mean? We can get the vectors. They're random or pseudo-random, like I was saying. You'll always get the same things by the same input, but we have to check what is what. And then we can use some input to get all the vectors, and it's pretty easy because it's all basically random. So this is the same as normal programming with a lot of math, which makes it worse. But basically, this is a library for Python that I'll show you later which one it is. But basically what we're doing is we're generating all the vectors, and we are making a matrix and using linear algebra magic and whatever. We are checking which of them are linearly independent by checking the rank. The rank is when you use the Gauss method to solve a system of linear equations, you get to kind of like the Medurenge form of the matrix. So you have all zeros on the lower part of the matrix, and you have something on your diagonal and something on your upper part.
Rank is how many independent
rank is how many independent vectors
you have linear independent vectors.
Yeah. So we use this to determine if we're finding more independent vectors by adding it to a matrix. If we find that the rank is higher, then we're on the right path. If we find that the rank isn't higher, we drop that line and add a new one, and so on and so forth until we get 256, I think. Yeah. So yeah, you make the vector. It's just a result from some table that was defined before. I'll send you the code. No, the code is on the videos I showed. I really recommend you watch the videos. It's really good. Yeah. And basically, you get the hash of whatever you want to get, and you get the hash of the grid plus the malicious command you want to run. In this case, is the flag. And when you put them together in the program, it hashes this together and gives you the result.
Get flag.
basically you get a hash that you know won't pass, because the only one that will pass is the one that's only grid. So you get that one, you get the one that's the grid plus the code you want to run, and then you have to find how to get back to the good hash. So you add whatever vectors you want, because you can do a calculation also by Gauss or whatever, that lets you add all the vectors necessary to get back to the original. One idea would be just to use the same evil command twice, but you cannot. You have to use other commands. So basically you're running back with all the independent vectors back to the original place we were with the grid command. This is a write-up by a person way more intelligent than me that solved it at the time of the CTF, but basically, as we were saying, Gauss, the grid command, we want to get flag, we add the independent vectors, something happens in the middle, we don't really know, and it works. But yeah, what tools do we use? Sage is the library I was talking about, which is for math in Python. It got like linear algebra and way more stuff that are connected to cryptography. Decode is a page that all the noobs like me use because we don't know how to do cryptography, so we just throw it out there and there's probably like the cryptographic solution to whatever. And math, shocking, I know. But anyway, if you like math and you like solving puzzles, that's a good one.
Wait, is Sage just a superset of NumPy?
It has the combination of, if I'm not mistaken, 10 different libraries that just together works. PPC, I think you by this point forgot what we were talking at the start, but PPC is Professional Programming Challenges. It's LeetCode, but on drugs. Basically what's about is basically all the hard challenges in LeetCode. You get that, but you have to program it in a certain programming language you don't like and have to figure it out by yourself. PPC, I mean, for every student that's right now studying computer science, you should probably do a bit of PPC at least to like get better at programming. During like when we start using the Discord and actually start learning, I'm probably going to send like one challenge of PPC a week, just and we'll get a prize. I'm not getting money, so you are not getting money, but probably the person who makes the funniest solution that works fast for PPC is going to get to be the first one to choose the teams for the CTF. So we'll see. But yeah, PPC gives you obviously a deep understanding of algorithms and everything to do with how to code well, effectively and fast. And yeah, code that works under time constraints, and obviously because it's during a CTF you have not a lot of time to do it, so that's what you learn. And go back a sec. Basically 12 of the 100 places there are to learn programming in a high level, but yeah, we'll look at it later. OSINT. I mean, I could have put a video, but you probably only know GeoRainbow, the guy that just like looks at a tree and just like finds where your underpants are, and you're like, what the hell is this guy doing? But basically what OSINT is just finding stuff you shouldn't, finding people in different social media based on a challenge. It tells you there's a guy with this name that wrote a comment about some movie in Reddit 50 years ago, and by connection to that you can just find who the guy is, where he works, that kind of stuff. On CTF it's like that, and also you have different pictures about places and you have to find where it is. But yeah, basically everyone is going to learn a bit of OSINT, because a lot of learning how to do cybersecurity is learning how to find stuff, be it information, be it learning resources. So there's some OSINT in everything. Forensics. All my homies don't hate forensics. Basically, forensics is a really, really interesting part of cybersecurity on the real side, meaning blue teaming, IDR, which is incident response, basically. And this is the things they usually do. Steganography is the art of hiding information in pictures, for example. but also analyzing memory dumps, network packets, Wireshark if you heard about it, looking at a lot of messages you shouldn't be looking at in basically, but it's interesting. I recommend everyone learns a bit about this. The problem is that in CTF sometimes this gets looked over, and it's the same as MISC that I will talk about in a bit. Degenerates, cool stuff, hacking phones. Basically, all three of these usually have really specified tools which are really interesting. Mobile hacking is really underdone nowadays. People look at Windows and Linux and Macs and whatever, but when it comes to hacking Android applications and whatever, only the pros do it, which is kind of sad because it's really interesting. Hardware hacking, I really want us to do hardware hacking. It would be super cool, but I have to check how expensive the equipment is. Like basically, it's spawn. Like in CTF, sometimes it's just looking at the results of radio communications, but on real life, usually hardware hacking is just grabbing, for example, a router, extracting the code in the chips, which you need obviously some specific equipment to do, and then doing binary exploitation on the code that's on the router. And for example, you can just reverse engineer it and change something, because there's like some routers that only work for some providers, for 4G for example, and you can change stuff around and put the firmware back into the router and change how it works. But also you can just find vulnerabilities. I have a friend that right now he's working on reverse engineering some firmware and finding vulnerabilities to exploit and have remote access to routers for some company. He didn't say which, wonder why. But yeah, it's a kind of niche. Yeah. MISC. I mean, it says it here. It's basically everything else that's connected to cybersecurity but doesn't really fit anywhere else. It's in any combination of challenging, wacky, fun, and terrifying. For example, let's say you probably all know some website that lets you run JavaScript on the web, which is like, yeah, we run this and we run that, and they run it on their own server, but it's really, really, really hunkered down, and it's really hard to break out of that sandbox. And MISC have some challenges that are like, well, you're in a sandbox for Python. You can only run this, that, and that. Some functions in Python, but you can run, say, like system OS, for example, because if you can run system, you can get OS. If you can get OS, you can read files. If you can read files, you can leak information, okay? So there, for example, some of the challenges are just breaking out of that sandbox, getting some abilities they don't want you to have, and just having fun. So now we finished talking about the different categories. I hope some of them were interesting for you. But now the idea is to start by yourselves. Trying to know everything as a beginner is really hard, basically because for each category you're doing, there's another guy doing just one category and putting 3 times the amount of time in it. So it's better to, at first, choose 1 or 2 categories and start working on that. I hope, like, from what you saw, you decided more or less what you're interested in. And when you choose your category, we're going to have groups. The groups aren't like exclusive. I'm probably going to go into web to help people new in web, but I also want to go into reverse engineering and Pwn, because that's what I'm interested in learning now. And I'm helping in web because I know, and I'm going to be a kid in the others because I don't know reverse engineering, like who does. Yeah, each category will have its own group, and you're going to learn by yourselves. I'm obviously going to provide you a lot of resources to start, and the people who already have knowledge in the different categories will provide more resources, obviously, and we'll help each other out to get better. And yeah, the objective is learn to fish. If you heard the habitu that says, if you feed a man a fish, he can eat for 1 day, but if you teach them to fish, they can eat for the lifetime. So yeah, the idea is simple. You're going to get the tools and a community to help you out to learn, but the learning is on yourselves. I'm not going to give you credits. I'm not going to get you a job, although I hope that by the learning you'll get one. And basically, you're going to what we're going to do is give you the information and the support that people need to work together and learn some more stuff. The idea is to get good at applied deliberate practice, which means learning and then playing CTFs. Autodidactic learning by self-sufficiency, and creative problem solving, which is like the whole idea. It's going to play when you pass it, but basically, mostly for teachers, I'm going to send this to different cybersecurity connected teachers. This talk, it's a really good talk by one of the managers of the, like a professor and a manager of the CTF team from Carnegie Mellon University. The team a couple of years ago was called PPP. You probably don't know like the scene of CTFs and whatever, but probably some of you heard of DEF CON.
Yeah.
DEF CON is one of, if not the hardest CTF in the world, and these guys at Carnegie Mellon won 3 in a row, which is insane. Yeah. How is it going to work? So this is from already 2 weeks ago almost. I was looking at a site called CTF Time where all the CTFs are hosted usually. The problem is, as you can see, Saturday, 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 which means if you're Jewish and you respect Shabbat, you can't play, which means we're going to host our own CTFs. How are we going to do it? I don't know, really. Like, we need a server. I'm trying to figure out how to get a server that doesn't cost an arm and a leg. I'm trying to figure it out. If anybody has a friend that has like 50 servers for some reason.
Is $4 a month an arm and a leg?
The problem is that I don't know what size it has to be. So CTF challenges usually come in Docker containers. If you have heard about it, basically it's just a self-contained environment, so your own machine isn't vulnerable. But the problem with Docker containers is they usually take a lot of RAM because the files are on memory and the different stuff is on memory, and then I don't know how many cores you need, so maybe it's $10 a month, maybe it's 250 shekels, so I'm just trying to get somewhere in the middle where we get something that runs, and we also just would like, I would probably host some challenges to do during the week, but CTFs would probably be once every 2 weeks. So I'm still trying to figure it out. Maybe I can work with the university. I'm not sure. Hopefully soon. Hopefully being I find a server and we do it. Next. The teams, as I said, each person will learn the things they are interested in. If you like web, you'll go more into web. If you like 2 things, you're going with both groups. You can come out and in of groups. Obviously, it's not like I didn't select this, you're not going to be in. It's just like a way to self-contain the different learnings and give the possibility of smaller groups to meet with each other. But once every 2 weeks, hopefully, we're going to have CTFs, which means obviously one category can't solve all the challenges because every CTF has a bunch of categories. So people from different categories will come together, and you'll have the chance to meet new people that you usually don't talk to and learn from them. Learn from the different categories. Maybe it turns out you start doing a CTF and one of the guys tells you how to solve a pawn challenge. You usually do web and you say, maybe it's interesting to learn this too. So you get the possibility to mix around and find new stuff. And if we find a CTF that's going during the week and not on the weekend, we're playing it. Like someone else is hosting, we are not paying, obviously we're playing. So yeah. Yeah, basically everybody, I don't know if there's team amounts, it's different in every CTF, but we're probably just all playing together, and if we manage to just go to the finals for some reason, then the best people are going, but like, we're all playing together, who gives a shit. The logo, that's fine. Have you? Yeah, I don't know if you saw the logo yet, but basically in 2023, I was bored, and I wanted to learn cybersecurity, and I tried to find a cybersecurity team in Israel, and I didn't couldn't find any. So on the same week, I just saw a video which was like World Nazi Club. I mean, I'll send it to you later. But basically, I found out that the guys who make the how's it called, the crypto whatever apes, the Bored Ape Yacht Club, are kind of Nazis. It's a long story. Basically, I just saw their logo and said, "Ooh, shiny." So I stole it. I flipped it. And that was the logo for my CTF team for like a year and a half. I mean, if it's stealing from Nazis, is it really stealing? and then when I decided to do a CTF team for the university, I said at least it has to be our colors, right? So there you go. That's the story. Hope you enjoyed it.
Is that gonna be our motto?
Yeah, so the learning. Basically, hopefully every category will have one person at least that has some prior knowledge and can point you in the right direction for everything. Like, not everything, like the starts. I'm not great at web, but I know web, so like people who are coming into web and are interested in learning that, then I can give some tips on what to learn, where to learn, what's more important, what is less important. I already posted and you have access to it, the resources for every category to start. I haven't finished the resources for every category because I was in the middle of doing this. So with time and with more people joining which have some experience, we'll get better resources to give to new learners. And I already posted the starting resources if anyone's starting from zero. I haven't posted the coding resources yet, meaning the stuff for people that don't know coding, but I think most people here are from computer science and know more or less what's going on. So you can go directly for the resources if it's web, if it's Pompon, and so on and so forth. There's a Discord server. I don't think I've said it enough. There's a Discord server, so we're going to host more stuff there. I did the WhatsApp group knowing that some people were going to say, "What the fuck is Discord? I'm not joining." So that's where this ends. Join the Discord. And hopefully we're going to do meetups. Again, each category will decide when they want to meet to talk about their topic in particular, so we don't have to manage, 50 people. So each category can manage their own thing. I have to find responsible people that are going to record everything so people can watch it if they can't attend, but we'll see how it goes. And we're hopefully going to host a presentation in another, 2 months or something before the tests, so we can see how we're going, how every category is progressing and where we're going next. So yeah, team shared resources. Honestly, I overcomplicate everything. There's the team shared resources, which is a view only or comment only folder, which means admins can add new resources and people, if you want to add more resources, just can comment on it and the admins are going to greenlight it. And if it's something illegal, we're obviously not going to allow it, or maybe only the Discord, I don't know. And this is the Discord. It's part of the Discord. There's like more things on there, but I already made like the different categories for people to start talking on it and start deciding what they want to learn. And the end goal, there's some interesting cybersecurity research, obviously. Meet other people interested in the field, make projects that impact the cybersecurity sphere. I don't know how many people here are already working in cybersecurity. I think only Yair right now. Prepare talks for a conference. Hopefully someone here, if everything goes well, I'll have to do a talk about this, obviously about the club on B-sides this year, but hopefully someone does some interesting research they want to share. Gain knowledge that will be helpful on future employment. Look, don't quote me on this one. I've been talking with people on the industry about bringing challenges to the CTFs that are provided by companies. So people that solve them and solve them well maybe can get a job, but don't quote me on that one. I have to.
So basically, what LeetCode does.
No, not LeetCode. Hacking challenges.
Yeah, no.
Yeah, but
basically, LeetCode does the same thing. It asks Google, Facebook, and whatever.
Yeah.
Give me
challenges. No, but the
the
difference with that is that we're probably going to be the only ones getting the challenges. So hopefully we'll get a first call on like whatever. But again, if everything goes well, don't quote me on this one. And is there any third-year students here? Maybe a final project in cybersecurity?
Already.
Yeah, on that?
Well, building a ransomware.
Ransomware?
Yeah.
We are going to put it...
Python.
Nice, you're going to put it on the uni servers?
Yeah.
I'm kidding, no. Nobody does nothing on the uni servers. I already got banned. It's not a good idea. But yeah.
Twice.
Wait, no, it was once. Any questions?
I mean, if you want, I can do a short presentation of like a default task for PPC.
I mean, like, this is the end of today on the presentations part. Later, we have another hour and a half in this class, so if you want to stay here and talk about like what categories you would prefer and whatever, we can do that. But yeah, different categories are going to start talking about what they want to learn and what they want to do as groups, and we'll see how it goes. They're already leaving. Fantastic. Anyway, any questions?
PPC is a website or?
No. PPC is a challenge category.
Oh, okay.
So in some CTFs you have programming challenges, and they just call the category PPC.
And there are resources for PPC in the drive and.
The thing about PPC is that it's just programming. So you learn programming, and then you learn applied programming, and that's just PPC. So I don't have yet put a lot of resources about programming itself on the resources, but any resource somebody wants, we can just find it and put it there. So if you want, I'll look at it a bit later.
PPC is more about algorithms and data structures.
Yes.
So
Principle solving of programming challenges, meaning you're trying to do it the best way possible.
yeah.
Other questions?
Really, if you want, I can just show like a default problem, it's marked hard in LeetCode, but it's not really hard.
Yeah, I mean, we can do that if people don't want to do something else.
Yeah.
And have you already thought of what category you're interested in? I mean, who's going to web? Some people, reverse engineering, PON. Is there anyone here who hasn't chosen? You haven't chosen?
I'm not sure. I have to be in one group or?
No, you can be in all 5 groups. It's your problem, not mine. So, look, if you don't get to finish your homeworks, it's not on me. That's the only thing that matters here.
That's where I'm going. Do my homework. But alright.
Did anyone ask something on the Discord?
If you have any questions for me, I'm here for the next 2 minutes. 2 minutes? Yeah, I have to go do my psychology homework.
Oh. Why did you choose to do also science and everything?
I want to change the direction of my career, hopefully.